Hello, good afternoon, guys. Welcome back from the Easter break. I hope you had a lovely time in 3 weeks of break. As you know, this hour from 4 to 5 is going to be a revision session. But before that, I'd like to make a few announcements. For tomorrow's test, number one, there are going to be 2 different rooms. The test is going to be held in 2 different rooms. And you should have got an email from me saying which of the 2 rooms you are allocated to. So please make sure that you go to the right room, because if you don't go to the right room, you may not be able to sit the test. All right, so please read my emails. Don't just press the delete button whenever I send you an email, guys. I spend a lot of time, guys, sending these emails. Just please don't ignore my emails, right? And number 2, oh, there it comes. Number 2 is your mark and your feedback.
Sorry, I'm the only one here having the aircraft in Institute, big event. Sorry, guys, I can't believe we forgot it.
Sorry, take your time.
Okay, so this is your side screen, and that's your main one.
Okay, thanks a lot, sir. Thank you. All right, guys. Shh. Number 2, your marks and your individual feedback will be sent to you before midnight of tomorrow. So please make sure that you check your emails. Okay, and number 3 is about the UEQ. It's really been a mess. It's been a real mess with respect to the unit evaluations questionnaire. It was open last week, but somebody at the university administration got the questions wrong. So it was closed last week. So it was reopened this week. And so if you have got the bonus question last week, please complete it one more time. The only thing I can say is apologize to you. And the people who made the fault, they don't even have the decency to apologize to you guys. I have to apologize on their behalf. And so if you haven't got the bonus question, right, please complete as soon as you can so that I can send you the bonus question. The deadline for the bonus question is the 22nd of May, which is the day before your final exam. And I must say that there has been some confusion about the final exam will account for 80% of your mark, and the test tomorrow will account 20% of your mark, and the bonus question will account for 2% of your mark. So the total will be 102%, right? And if you get more than 100, then you will be scaled back to 100. Okay? So that's the marking scheme for this course. And about the test tomorrow, because that's why we are here today, it's not going to be a difficult test unless you prepared for it. Unless you did not prepare well for it. I mean, if you had prepared, if you had gone through all the 10 in-class tests and all the 10 exam papers and the solutions, then you should really feel fully confident for the test tomorrow. I mean, you should feel full of energy, full of confidence, all right, full of adrenaline, going for the test tomorrow, right? That's how I think that's how you should feel. You should if you had gone through all the material that I had put online on my website for this course, right? You will feel right now, sitting in front of the exam paper, the test paper tomorrow, you will feel a bit like you will feel a bit like this guy here. Yeah. You know who this is, right? So this is how you should feel tomorrow if you are really prepared for it, going through all the materials that I had given you for this course, right? All right. Okay, guys. Now I don't want to waste more time. Now, can you there's a colleague of mine who's seated in front. He will come around and ask you any particular question you like me to do right now. Stu. Yeah. So he will come around and ask you questions that you like me to do right now. So if you have any question, just please give it to him. All right. So you can shout at me, and you have any particular question you like me to do right now. Any past in-class test, any past exam paper questions, or any other question? Because I told you by email that I told you by email that the purpose of this class is revision. So only you guys need to tell me what questions you would like me to do. So if you have any questions, please, could you tell that to my colleague, please? If you have any particular question you'd like me to do now. Yeah.
There's two questions. One is asking about indicator function tomorrow, would there be an exam? And then the second is midterm 2016 question 2.
16.
Yeah, I see it. And another question actually about indicator function.
All right. Do you like me to? I know a number of you asked me by email whether do you like me to do this question? Yes? All right. So this is question 2. Right? All right, you should read the question, guys. I'm sure you read it already. You're told that x1 and x2 are IID uniform on the interval from 0 to theta, and y is the minimum of the two. And it also says that the only random variable that you observe is y, and you don't observe x1 or x2, right? The first part is to find the CDF of y. So remember the CDF is defined as this, yeah? So this is the probability that the min of x1 and x2 is less than y. Okay? Now, I'm going to rewrite this as I'm going to rewrite like this. Okay. Now, if the minimum is greater than y, then that implies that each x has to be greater than y. Yeah. Okay. Now, because x1 and x2 are independent variables, you can write this as the probability that x1 is greater than y and x2 is greater than y. Okay. Now, this, again by the complement rule, this can be written as okay. Now, what you have here is the CDF of x1, and what you have here is the CDF of x2. Now, remember, x1 and x2 are uniform variables. So, if you look at the lecture notes, guys, if you look at the lecture notes for the CDF of the uniform distribution, you will see that this is simply y minus 0 divided by theta minus 0. And this is also the same, y minus 0 divided by theta minus 0. Right? So what you have is okay. So this is the CDF of y. Is that clearer now or not? Yes, guys, or no? All right, that was the part 1 of question 2 last year. Now, part 2 of question 2 is to write down the likelihood function for theta. Right. To do that, okay, let me put this over here. Maybe it's too large. Right. The likelihood function of theta, because, as I said before, we only have one observation and one observation on y. Therefore, the likelihood function is the same as the density of y, right? Because you remember, likelihood is normally defined as the product of the PDF over the n observations, right? But here n is equal to 1, right? And therefore, the likelihood must be the same as the PDF, right? Now, what we have here is the CDF. So to find the PDF, you need to differentiate you need to differentiate this, right? So if you differentiate this, you get minus 2 so this becomes 2 over theta times 1 minus y over theta. Okay? Right. So this is the PDF. This is the PDF of y, yeah, and therefore the likelihood function at theta must be equal to this. So this is the answer. This is the answer for part 2, and the remaining parts I think they are not difficult, are they? Are you okay with part 3, 4, and 5, or you want me to do that too? Guys, are you okay with these parts or no? 3, 4, 5. Yeah. Yes. Are you guys okay?
If we can remember certain
Yeah, you will get partial credit even if you don't get the answer correct. If your answer is wrong, but you've shown some details of the working, then you will get partial credit. And but if you just write down the answer without any details or with little details, then you will not get any mark. Okay? I mean, it's possible that you probably remember the answer from somewhere, but you didn't know how to work it out. Then in that case, you wouldn't get any mark. I mean, you have to show at least some details leading to the correct answer, or even if you got the answer wrong, if you can show some significant details, you will get partial credit. Yeah. And with respect to the indicator function, I know some of you asked me this before, whether the indicator function will come or not. I mean, I don't want to give the whole questions away, so I cannot tell you like whether it will come or not, right? I can only tell you that you can. I think I always told you this before, that for any question on MLE, let me repeat this. Let me repeat this one. If I ask, this applies to the final exam. Any question that you will get on MLE, right? The first step is to try this standard approach for finding the MLE, right? And if the standard approach does not work, when I say it does not work, it means like you get answers like infinity or minus infinity or answers like that. If you get such answers, that means it doesn't work, right? So if it doesn't work, then you can try the indicator function approach, right? I mean, this applies to any question, whether it's in the test tomorrow or the final exam in 23rd of May. Sorry, this is the approach I would like you to take, because certain questions, I think if you had gone through all the 10 midterms and the 10 exams, you would have seen there are certain examples where the standard approach will work. So that means you don't need to try the indicator function approach, right? And there are certain examples where the standard approach will not work, but the indicator function approach will work, right? Okay, and so on. And there are also examples where the standard approach and the indicator function approach both give the same answer, and they both work. All right? Okay? Those are a different kind of examples, right? So, like the example, this one here. Like in this example, the standard approach and the indicator function approach both give the same answer, and they both work. Yeah. Okay. All right, guys. So I cannot. Yes. Yes.
Would you be able to do question 33 from the example?
33, you said. Yeah, I got a copy. Yeah, sorry, I got a copy here. You mean is it the job? Is it this one here, sir?
The one about the geometric.
Yeah, the geometric. I thought I did that in the class, guys. Didn't I do this in the lectures? I can do it again, but I've got no problems. But I'll do it again, guys. But I thought I had already done this in one of the lectures. This is example 33, which says that you have all right, so all right, so it's the product of the probability mass function. So this will be right. So this is the likelihood function. So I'm taking the standard approach, guys. The next step is to take the log of the likelihood. So it will be n log p plus okay, and the next step is to take the derivative of the log likelihood with respect to p. So you get this, and set this to 0. If you solve this equation for p, you will get p hat equal to n, correct me if I'm wrong, divided by which is 1 divided by x bar. Now, this is not enough to show that this is an MLE, because whenever you get a one parameter distribution, like what you have here is a one parameter distribution, you must show that the second derivative is less than 0. All right? So we need to find the second order. We need to find the second order derivative, which is the derivative of this. Now, this is less than 0 because the reason that this is less than 0 is because there is a minus in front of this, and there is a minus in front of this, and this guy here is always greater than or equal to 0. The reason that this is greater than or equal to 0 is because of the following. Because remember, xi is a geometric variable, right? So by definition, it is greater than or equal to 1 for every I, right? Because the geometric variables are defined on the integers 1, 2, 3, up to infinity. So the sum of xi must be greater than or equal to n, right? So the sum of xi minus n must be greater than or equal to 0, all right? Okay? So this thing here is greater than or equal to 0. And because of the two negatives, this whole expression must be a negative number, and hence this must be an MLE. Yeah, so please make sure whenever you get a question on one parameter MLE, always show that the second derivative is negative. I know in some of the solutions I haven't done it because I was too lazy, I guess, but in the exam or in the test tomorrow, you must do that, right? You must show that the second derivative is negative. Yeah? Okay. Other questions, guys? Feel free to raise your hand and ask me any questions. Yes?
Do you have copies of the past midterms? So I've got the question number and date, but I don't.
Yeah, I got copy. Yeah, I got them here. Yes.
Oh, great. Would you be able to do question 2 from 2012/13? Specifically the variable part.
Do you mean this one? Do you mean this question here?
No, sorry, I mean from the past midterm.
Oh, sorry. This is. Oh, yeah. Sorry, man. Sorry. Oh, yeah. This one. Is it this one, sir?
Yes, please, yeah.
Yeah. Okay. All right, guys. Now, this is I'm sure all of you have done regression. Now, in regression, the only random variable on the right-hand side are the EIs. EIs are ID normal with these parameters. And the beta and the XI they are fixed, right? The beta and the XIs are fixed numbers, right? So what does this imply? It implies that yi is a fixed number plus a normal variable with parameters 0 and sigma squared. Okay? Now, if you add a constant, this is a constant, right? If you add a constant to a normal variable, it will become do you see that or not? If you add a constant to a random variable, the mean will change, the variance will not change, right? Okay? Now, to find part 1 is to find the likelihood function, right? Remember, the likelihood function is simply the product of the density function I from 1 to n. I mean, that's the definition I've given you, all right? So it's the product of the density function of this I from 1 to n, which is The density function of this, I'm sure all of you know, is root of 2 pi times sigma yi. Mean is this squared bracket bracket. Yes? Do you see where this comes from, guys? This is the density of the normal distribution with parameters this and this, right? So this is the likelihood function. So if you can simplify this, you will get right? This is what you will get. I think so. So this answers part 1 of this question. Part 2 is just. Do you want me to do the other parts too?
Would you be able to do the variance part 4?
Part 4. Okay. All right. Let me do part 2 too, because it will help me to do. All right. So to do part 2. In order to find the ML estimator, you take the log. So this is the log of the likelihood. And we are assuming there's only one parameter that is unknown, which is beta. All the others are known. Sigma is we are assuming that sigma is a known parameter. So it's not a parameter. Sigma is a known fixed number. So taking the derivative with respect to beta gives you right, gives you this, right? And set this to 0, you get this, yeah? And next page, put this over here. Guys, yeah, put this over here. So simplifying that, guys, you get this. So beta hat is equal to right, this is beta hat. Now to make sure that this is an MLE, you must show that the second order derivative is also negative. So the second order derivative with respect to beta, right, is the derivative of this guy with respect to beta. That will be, if I'm not mistaken, minus and this is clearly a negative number, right? And hence, beta hat is an MLE. All right, now let's move to the fourth part for the question. You were asking me about the variance, right? All right, so part part 4 is to find the variance of beta hat. So it's the variance of beta hat, which is the variance of right. In this expression here, as I said before, xi is a fixed number. It is not a random variable, right? So you can pull this guy outside the variance, right? So it becomes now, the next step I'm going to do is I'm going to take the variance inside the summation, right? When you take right, when you take the variance inside, because xi is a constant, you need to square it. And the variance of yi, now you should return to this slide, guys. I said that yi has this normal distribution. So what is the variance? The variance is? Come on, guys. If yi has this distribution, the variance of yi equal to sigma squared, right? So this guy here is equal to sigma squared, right? And therefore, the answer is sigma squared divided by Is that clear, guys? You're right. Any other questions, guys? I'm sure you have lots of questions. Or you can email me 2 o'clock in the morning tomorrow, or 3 o'clock in the morning. I can send you emails. Sorry? Yeah, this is why you should get your elementary math correct, sir. You have xi squared here, right? So you have an xi squared here. That means you can only take this outside. You can't say that this is n times sigma squared. I mean, you should go back to the course website. There are useful tools on how to simplify sums, how to simplify products, and so on. I think that's the kind of thing you should learn, guys, before tomorrow. It's not too late, you know. It's like things like this, for example. If you have a sum of a constant c times, say, zi, right, say I from 1 to n, right, then this is the same as c times the sum of zi. This is one of the formulas I had put online on my website. You can't say that this is c times n times c. You can only take the c outside. Yeah? Other questions, guys? So, yeah, I mean, the advice is you should be able, you can do all the 10 past test papers without looking at the answers. And also she can do the past exam papers for the past 10 years without looking at the solutions. Then you should feel extremely confident. Right? It's like Usain Bolt going for the 100 meters. You know, that's how you should feel confident when you come to the test tomorrow. Yeah. Any questions, guys? Right, yes.
Did you take the 1340 part 5 on the one?
Is it the test or the exam? Hello? Test. Guys, listen, just keep quiet, please. Is it this one, sir? Hello?
Yeah.
Part 5. Yeah, there was a mistake in this year's exam paper. There was a mistake. It should have been. I think I pointed this out in my solutions. I'm sure you read my solutions, right? The solutions was, I mean, there was a mistake in this year's test paper, sir. So the correct form should have been a over 2 minus 1, and this here ai divided by 2 minus 1. Anyway, I can still do it. So this is question. I think this, okay, part 5. Well, if you look at the previous part 4, the answer for the MGF of x1 plus x2 at t was, I think it was, I'm trying to remember what it was. Was it 1 minus, yeah, 1 minus 2t minus a1 plus a2 divided by 2. Is that right? This is the answer, right? I mean, this is part 4 of question 1 from 2013-14, right? Now, if you look at this, guys, now what you have here is the MGF of a chi-squared random variable with df, degree of freedom, equal to a1 plus a2, right? Because remember, in the lecture notes, let me see if I can find the lecture notes. Here it is. Do you guys remember this, guys? This is the MGF of a chi-squared variable with degree of freedom equal to nil, right? So therefore, this one must be the MGF of a chi-squared variable with degree of freedom equal to a1 plus a2. So the answer to part 5 is that x1 plus x2 has a chi-square distribution with parameters a1 plus a2. That's the answer, sir.
So does that change it from the gamma one?
Because yeah, the chi-squared is a special case of gamma, right? Okay, you can. Okay. If you are confused, I can say that this guy here can also be written down like and this can be written down further as now. You should compare this with should compare. Just a minute, give me a sec. Right, now, this one here, this is the MGF of a gamma random variable, right? And this is the same as this one. The only difference is that lambda equals a half, and your A is this one. So another answer to the same question is that this is the MGF of a gamma random variable, right, with lambda equal to half and A equal to A1 plus A2 divided by 2. So both answers are acceptable. Either this answer and this answer, they are both the same actually, because the chi-squared is a special case of a gamma distribution, right? Yeah. Are you guys okay? Any other questions, guys? I'm sure you have lots of questions. Yeah, and one more announcement, guys. After I send you the marks tomorrow, could you please complete the unit evaluations questionnaire? Because the sooner you complete, the sooner I can send you the bonus question. All right? All right, guys. I'll see you guys tomorrow, and good luck. All right? Hello. Sorry? You don't have, okay, have this. Do you have the lecture notes? Okay, you can have them. Hello.
Looking through this integration over here. Yeah, no, that one. Looks like this one. If, when you work out integration, work out this. But if two manifold one of the b is positive, that will go to infinity.
Yeah, I'm assuming it's negative. Yeah. Otherwise,
But
you
that's
can't
not
integrate.
stated in the question. So
Yeah, I know.
it should be a bit difficult.
Yeah, you have to assume. Otherwise, it's on the wrong.
Would that probably be stated in the question?
Yeah, in the future I will, but this is, I should have.
Otherwise,
Yeah, I know. Yeah.
If you're doing an MGF question and then you require the MGF to work out later on, and you work out incorrectly, you get other parts of the question. What should you do in that case if you aren't able? Because the first question should be work out the MGF.
So the first question you will get the full mark. For the second you get plus 50%.
Okay, yeah.
You've shown the correct working, but your answers are wrong.
Yeah.
So you get 50%.
Okay, yeah. Thank you. So if you don't know what the MGF is or you can't work it out, just put one in that you know and just go through it.
Yeah.
Thank you.
Yeah. Right. Well, I can't. Try any effort. I'm not supposed to help you with the bonus question, but I know this is a bonus question. But I mean, try the indicator function or the standard approach. Well, try the standard approach first.
I know it doesn't work.
Okay.
So I didn't.
Okay. Try the indicator function and see if it works.
I know it doesn't work.
It doesn't work. I don't know. I mean, I can't. Because this is a bonus question. I'm not really supposed to help you with the bonus question. Yeah, I know.
I just asked before.
Yeah, you can use the indication function directly. Yeah.
Try to get it also is enough.
It's not working.
No, it doesn't.
It did work. Okay, then that's good then. But I can't tell you the answer though because it's a bonus question. So yeah, try your best and submit your answer before the 22nd of May. Yes, 22nd of May. Yeah. You finish? You give it to me now. Oh, you can give it. You put your name. Well, you have put. Okay. Thank you. Yeah, I will mark it later.
You should ape it together.
Yeah, I will staple it later. Yeah. Yes, sir. How are you?
When I emailed you, you said that you didn't need to know any PDFs.
Sorry?
Do we have example?
Yeah. From 5 to 6. Yeah, we have an example class now.
Okay.
When I emailed you, you said you didn't need to know any PDFs or anything, but on that you needed to know the chi-square, you need to know the moment generating function of the gamma.
Yeah, that's for the previous exams, the previous test, not the one tomorrow.
Okay,
For the
so
one
you just need to know just the problem sheet.
Yeah, for the one tomorrow, you need to only remember the formulas in the website.
Okay.
Yeah, because every year the formulas are different. You see, the formulas you need to remember for last year's, it's not the same as the one
Oh,
this
so
year.
so you said which ones?
Huh? Yeah.
Ah, right.
Yeah.
Do you want to know what about the MGF gamma?
I can't tell you that, but I mean, the only thing I can tell you is what formulas to remember. The formulas to remember are the ones on my website. You know the link I'm talking about.
When it's working out the MGF, would we have to know what the function was off by heart? Will it say what the function is and then work it out?
Yeah. It will tell you, it will give you the form of the PDF, then it will ask you to derive the material.
So it'll tell you what it is, so you have to know.
Sorry.
PDF.
It's like,
The PDF will be given in the question. You don't need to know by heart.
Right.
It will be given explicitly as part of the question. So you just need to use that to find the MGF.
how many is there? Is there loads? MGFs you've got, right?
No, only one.
No,
No, I mean lots. You mean lots in the north. You mean.